All right, so let's check your answer. What percent of the cars get between 20 and 30 miles per gallon? Did you get 59%? If not, let's talk through this and see how this problem is done. All right, so let me change colors here. Let's draw our picture. We draw our normal model. Okay, it's kind of a flat one. We know still our mean is 24, so I'm still going to mark that. And 20, we can see by looking at this picture up above, is not quite a full standard deviation below the mean. So I'm just going to kind of put it right about there. All right, and then 30 is exactly one full standard deviation above the mean, right? Because the standard deviation up here we know is 6. So this is exactly one full standard deviation. So the percent that get between 20 and 30 miles per gallon is this percent right here, this area in between those two boundaries. So how do we find that? Well, basically we need to get the z-score for both of those values. So I denoted them as z sub L and z sub U for lower and upper. So the lower z-score, the one with a value of 20, 20 minus the mean of 24 divided by the standard deviation of 6, gives you negative 2/3 or negative 0.67. And then the upper, 30 minus 24 divided by 6, is exactly one standard deviation away, which we already knew. All right? So again, some notation here. We really haven't talked about notation. You can write your answers. Remember, all answers have to be labeled or put into a sentence. You have to have that clear communication. So here we can say P, this means percent of or probability of, it can mean either thing, that the Y value, the gas mileage, the miles per gallon, is between 20 and 30. Don't get hung up on the equal to parts of the inequalities. You can include them or not include the endpoints. It doesn't matter. That's an infinitely thin boundary there, so it doesn't matter if you include it or not in terms of the percentage. Okay, it's the same. You can write it in terms of the actual values, or you can write it in terms of the z-scores. Because the probability of saying the miles per gallon is between 20 and 30 is the same as saying the z-score between negative 0.67 and 1. So you can use either one. You don't have to use both. Pick whichever one you like best. All right, well, how do we get this? Well, remember, we have these charts we can use for finding the percents from the z-score. Well, for our positive value over here of 30, let me erase these so this is no longer on here. Okay, we can think of this as our 30 right here. We know that that has a z-score of 1, right? So just go to 1.0 right there. So approximately 84% lies below that value. So if we go back to our picture, oops, right here, no, sorry, right here, 84% would be all of this to the left of 30, okay? Now for the z-score of 20, okay? We know that z-score is negative 0.67, so we go to our chart. Now for the negative z-scores, so now we're using this chart. I use the graph to figure out which chart it is right away. Negative 0.67, if we slide on down here, negative 0.6, there's our tenths place, and then we need the 7 in the hundredths place, which is the third column here from the left. So I'm going to go back down and see where they intersect, and that would be right here. So approximately 25% is below the 20. So 25% is this right here. Okay? So how do we get the purple, what we're really looking for? Well, I'm sure you figured out by now, just 84 minus 25, and that gives you the 59% we got right here. Okay? So take a minute, think about that, hit pause if you need to, and maybe write some more work down here or write an explanation to yourself on where this 59% came from so that you have that information when you go back to study at a later date. Okay? All right, now, next problem. What percent of cars get greater than 40 miles per gallon? This is actually an easier problem than the one we just did. So again, hit pause if you want to and try it by yourself and see if you can get the right answer. All right, you're back. So did you get about 0.38%? A very, very small percentage, less than 1% of all cars get more than 40 miles per gallon, which that kind of makes sense. I don't know too many people who get more than that. Although I'd say that maybe has changed now with the advent of more electric cars being purchased and on the road that we might. This data is probably not, it does not reflect those new vehicles that we're seeing on the road. Okay, so again, look that over. If you have any questions, write them down now. Write them in the margins so when you come to class tomorrow, you can ask me, where did that come from or where did that come from? and you can clear up your questions. Okay, so take a minute, hit pause if you need to, and take a minute to do that. Okay, flip the page, and you'll see this page right here. All right, let's talk about a little bit different type of problem. Describe the fuel efficiency of the worst 20% of all cars. Okay, so again, let's draw a picture. That's the best way to start to kind of make sense of the problem. We still have this mean miles per gallon of 24, right? And a standard deviation of 6. We're looking at the worst 20% of all cars. Well, that is probably those cars right here, right? Because getting less gas mileage is worse. So we are wondering what gas mileage corresponds to the worst 20% of all cars. Okay, so there's our picture. All right, well, what do we need? We know we have the mean. We know our standard deviation is 6. We're looking for this value here, which we generally call a y value. So that's what we're looking for. Okay, think about our formula for z. Z is equal to the y value minus the mean divided by the standard deviation. Well, we have the mean, we have the standard deviation. We're looking for y, so to be able to solve this equation, we need to know what z is. Well, can we get z? Yes, we can. We can get it from this percent right here because our chart, remember, relates z-scores to the percentages. So we're just going to use that chart backwards. So we want to go to the picture that's looking at the lower portion, you know, where the z-score is negative. So go back to that chart right here. And we're looking for the percent in the body now, in the body of the table that corresponds to 20%. So look over this table, and we can see that 20%, the closest thing we can get to 20%, is this value right here. Now, what z-score does that correspond to? A z-score of negative 0.8, and then we have to go up and see what hundredths place we're talking about, and that would be a 4. So negative 0.84 is the z-score that corresponds to that value. So z equals negative 0.84. Okay? All right, so now that we know that, we've just got a simple equation to fill in. Just going to do a little algebra. So negative 0.84 equals y value that we do not yet know minus the mean. Oops, that's just a minus sign. Mean of 24 divided by the standard deviation of 6. You better be able to do this algebra. Multiply by 6 on both sides, right? When you do that, the next thing you get 6 times negative 0.84 is how much? Some number, which I did not write down. And then we need to, because this is going to cancel over here, we need to then add 24 to both sides. So when you do this arithmetic over here, 6 times negative 0.84 plus 24, you should get approximately 18.96 for y. And so 18.96, or about 19 miles per gallon. That's the fuel efficiency. About 20% of the cars get less than 19 miles per gallon. Okay, and you would just want to write that out in a little sentence to indicate that you know what your answer represents. All right, so think about what we just did here. We went from a percent, in actuality it's a percentile, right? Because it's always a percent below a certain value. So you start with your percentile. What did we have to get from there? We had to get the z. And then what could we get from there? Then we could get the y. All right, so what did we use to get from the percentile to z? You can use your chart. That's what we use to get there. Okay? And then how do we get from z to y? Using the formula. Okay? And I like to compare this to what we were doing on the front page. On the front page problems, we were starting with a y, right? And then we were using the formula. Sorry, I'm working on a desktop here instead of the smartboard. A little easier to write with the mouse though than my laptop. From the formula, we got z, right? And then we used the chart to get our percentile that we needed. Percentile. Okay? So if you think about that, the z-score here, that z-score is always your stepping stone. It's always the link between the value of your data set and the percentile that it corresponds to in the normal model. So keep that in mind. Z is always the stepping stone. It's always what you're going to have to find first. Okay, one more example. Pretty much the same thing, but just a little bit different, asked differently. What gas mileage represents the third quartile? Think back to September. What is a quartile? What's the third quartile? Well, we know the third quartile is the what? It's the 75th percentile, right? So, whoops, let's get a color but you can see better. 75th percentile. Okay? So, let's show that in a picture. All right? 75th percentile is the point at which 75% of the data is below your boundary. Okay? So now that you know that, it's a very similar problem to Part D. I want you to go ahead and see if you can figure that out and do the remaining example on this page, E and F. All right, you should be able to do both of those. You should have your chart by now, so you can do that. Otherwise, look at the appendix in your book. It's in there. And then we'll see again how we can use technology to do these types of problems when you come to class tomorrow. Again, don't forget to write down any questions, anything that you're confused about. Write it down now so when you come to class you can ask. All right? See you tomorrow.